In this section, we're going to find the inverse of logs. So remember when we first started finding the inverses, what we did is we switched x and y. And what we can do is we can use Desmos to help us verify our answer. We're going to graph the original function and we're going to graph our answer. And the graphs are going to be reflections across the graph of y equals x. So here's just a picture of an example that we've got right here. So if we graph g of x equals 3 to the power of x plus 6 over 4, and then the answer to that, or the inverse of that, will be log base 3 of 4x minus 6 when x is greater than 3 over 2. So if we graph y equals x, so remember y equals x is that diagonal line. We can see that the purple and the red line are reflections of that. And so you can use Desmos to help you verify that. So logs and exponentials, remember exponentials is when x is in the exponent. So you use a log to find the inverse and vice versa. So if you start off with a log, you change it to an exponential to help you get the inverse for that. So starting off with the first one here, we switch x and y. So we have x equals negative 10 to the power of y over 2. And what we're trying to do is isolate the power, isolate the negative 10 to the y power. So I'm going to multiply both sides by 2. So if I multiply this side by 2, multiply by 2, and so then we'll get 2x equals negative 10 to the y power. We also want to get rid of that negative, so it would be like multiplying by negative 1 or dividing by negative 1 either way. So then I have 10 to the power of y. Now I can change it to a log. So remember, the 10 is the base, so log base 10. And remember, this is what we set it equal to. So we have negative, didn't leave probably no space there, negative 2x here, and set it equal to y. And so this is our answer. This is the inverse. And so if we look at Desmos, so I've already got a few already plugged in here to save us a little time. Here's the graph of y equals x. Here was my original problem, and then here was my inverse. So if we look at this, this one's a little bit hard to see, but if I kind of zoom in here, that is going to be a reflection across, like if I really zoom in, we can see that that's a reflection across the graph y equals x. If I were to fold it across that, those would be reflections. All right, so I'm going to turn those off. All right, so if I look at the next one, remember f of x, that is the same thing as y. That's just a fancy y. So if I switch x and y again, x equals 2 to the power of y plus 9 minus 5. And again, we want to get that part by itself. So if I add 5 to this side, now I can change it to a log. So I have log base 2, and then I have x plus 5 because we set it equal to the power. And then I want to subtract 9. And then technically we don't want to put that y right there because it started off with f of x. So what we'll see right here is we'll see it written like this. So that's really our true answer. They're not going to put the y there. It's the inverse of f of x. So that is going to be our answer. And if we want to verify in Desmos, there was our original problem. Got to zoom way out here, and we can see that those are reflections across the graph y equals x. Now, this one ends right here, and that's okay, but we do see that the black and purple graphs are reflections of each other. All right, so on this one, again, it's got a g of x, but remember, that's the same thing as y. So if I switch x and y, so I'm working to get y by itself, y by itself, so I want to multiply by the 4. So I have 4x equals 6 to the power of y minus 4, and I need to add the 4, so I have 4x plus 4 equals 6 to the power of y. Now I can take the log, so log base 6, and then 4x plus 4 equals y. And again, we start off with g of x, so I should really put the inverse of g of x right there as my answer. And if I want to verify in Desmos, there's my original problem, there was my answer. And this one actually crosses my line y equals x, and that's okay. They are still reflections of each other, so I can verify. Now, just as a side note here, when you are working on the EOC, if you're given multiple choice answers, if you forget how to do this, compare your original, like what they give you, and look at your multiple choice answers, plug those into Desmos and see which one is the best looking reflection, and that can help you get your answer. Okay, so on this one looks a little tricky, but remember, just start off by switching x and y. So 5 to the power, so this has a fraction as a power. Oh, I forgot to change my y there. So y plus 7 over 6. Okay, so I'm going to multiply by -4. It's the first thing I'm going to do. So I'll have -4x equals 5 to the power of y plus 7 over 6. Okay, so I've got the 5, I've got that base isolated, so I'm ready to go ahead and change it to a log. So I have log base 5, and then -4x equals that power of y plus 7 over 6. So then now I want to get the y by itself. So I'm going to multiply by the 6. So multiply by the 6. I'm just going to stick that out front. So I have 6 times the log base 5, -4x equals y plus 7. And then I need to just subtract 7 now. So I have 6 log base 5, -4x, and then minus 7 equals y. All right, so we're going to keep moving on. We're not going to look at that in Desmos. Again, this is just a y. So I have x equals 5 to the power of x plus 6 over 3 to the power of 1/3. Oops, and again, I forgot to change that to a y. Sometimes I get a little carried away here. Okay, so if I want to get rid of this 1/3 power, I'm just going to times that by 3. I'm just going to raise it to the 3rd power is all I have to do. If I raise it to the 3rd power, 3 times 1/3 will cancel that out. Okay, so if you have fractional exponents, just raise it to a whole power is all you have to do. So now I have x to the 3rd equals 5y plus 6 over 3. Now I can multiply by 3. So I have 3x to the 3rd equals 5y plus 6. And now we want to subtract 6. And now I'm ready to take the log since I have that base of 5 isolated. So I have log base 5, 3x to the 3rd minus 6 equals y. And remember, we start out with f of x. So I'm going to write inverse of f of x. Okay, so very similar. I have a fractional exponent over here. So let me rewrite this with my y in it. So with the fractional exponent, I'm just going to raise this to the 2nd power. And that gets rid of it, okay? I'm going to multiply by -2 now. So I have -2x squared equals 3 to the power of y minus 4. And so this is done very similar to the last problem that we just did. I'll add 4. And now I can convert to the log. Log base 3, negative 2x squared plus 4 equals y. And I started out with g of x, so I'll write inverse of g of x. Okay, so that does it when I have an exponential function. I'm going to a log. Now I'm starting with a log, and I'm going to an inverse. Okay, now remember, when we don't have a base here, we understand that it's a 10. Again, I'm just going to switch my x and y's. If you want to write that 10 there, you can. Okay, and so if I change to exponential, I have 10 to the power of x equals negative 2y. And if I solve, I'm just going to divide by the 2. I didn't mean to put a negative there. And that's my answer. Now, this one was like the same problem that was on the front, so I'm not going to check it because, we've already checked it, but I was just showing you how we're just reversing our steps. All right, but if we look at this one, so if I switch x and y, all right, again, you want to isolate this before you change it to exponential. So same thing, you want to isolate your base or your log before you change it to the other version. So I need to subtract 10. So x minus 10 equals log base 4 of y. Now we can change it to exponential. So it's going to be 4 to the power of x minus 10 equals y. All right, so now that's my exponential function. If I want to check that in Desmos, so it works both ways. So there was my original function, and there was the answer that I got. And you can see that they are reflections of each other. All right, let's look at 2 more. So I have x equals log base 5. Oops, that should be a y. Y plus 5. If I want to change it to exponential, that will be 5 to the x power equals y plus 5. And I just need to subtract that 5. Oops. 5 to the x minus 5 equals y. And on our last one here, so remember we need to isolate this. We want to isolate this part right here. The negative 4x is in parentheses, so it stays with the log, okay? So let me go ahead and change my x's and y's. All right, so first thing I'm going to do is add the 7. And then what I want to do is divide by this 6. So I have x plus 7 over 6 equals log base 5 negative 4y. Now I can change it to an exponential. So it will be 5 to the power of x plus 7 over 6 equals negative 4y. And then I'll divide by negative 4. So I have 5 to the power of x plus 7 over 6 over negative 4 equals y.